Hi everybody, my name is Fei, and here I'm going to share with you my Inside Data Science project tagging Hubble, where I built a NLP-powered search engine for Hubble observations. And this is a consulting project with Space Telescope Science Institute. I'm sure most of us have heard of Hubble Space Telescope, and that's because it's one of the most scientifically productive observatories in the world. Datasets like this image and their metadata have been used to generate thousands of publications, hundreds of PhD theses, and a Nobel Prize, among many achievements. So scientists, of course, want to further leverage these datasets for scientific discoveries. However, these datasets are hard to track down. In fact, if you go to the Institute's website and type in a topic such as galaxy evolution, you will get hundreds to thousands of results, which include workshops, news, papers. Some of them might lead you to datasets, but that's a lot of information to dig through. So my solution is to build a search engine that's dedicated to Hubble datasets. And now let's see how it works. So this would allow scientists to search Hubble datasets by keywords. And if we just type in a keyword, or let's try galaxy evolution to compare, it will lead you to archive of datasets and proposals. And if you click on one of the item entry, you will actually be able to see the data associated with that datasets and proposal. So how did I do that? Most of you might have seen that the datasets are associated with the proposal, and that's because in the field of astronomy, in order to make observations on Hubble, researchers have to submit a proposal to apply for time, and that's why each set of data is uniquely linked with the proposal. And these datasets were used to generate publications. So the raw data I have are publication data and dataset information, which I scraped from the website you just saw. So the first step in my project pipeline is to use NLP to extract keywords from publications. And these keywords can be single word like supernova, or it can be named entity like Abell 1300, or it can be phrase like galaxy evolution. And the next step is then to map those keywords to datasets based on the associations between them, which can be obtained from the information, the metadata information of the publications. So the algorithm behind that, first I pre-processed the full text data, which includes parsing, tokenization, and stop word removal. The cleaned up words were then passed through an algorithm including phrase detection, more stop word removal, and a TF-IDF model to get meaningful keywords. So an important note here is the stop words before phrase detection and after phrase detection are different in that the former are true stop words like obtain or significantly, but the latter are words that might contribute to a meaningful phrase. For example, star. Star cluster is a meaningful keyword that a scientist would search for, but star isn't. So that's why you want to keep those words in before the phrase detection, but want to remove them afterwards. Otherwise, they will dominate this the ranking. So these took many iterations, and as you can see, in the earlier iteration, most of the words we get from IDF model, TF-IDF model, are actually either stop word or true stop word or a stop word after phrase detection. And that's actually how I constructed the two vocabularies. And at a later iteration, we will actually get some real keywords. So the next step is quite straightforward, where we map keywords from publications to datasets based on the relational table between them. And now we have datasets that are labeled with keywords. We need a metric that can rank them by relevance. And this metric is a relevance score, which captures information including frequency of word appearing in our publications, citing dataset and citation of a dataset, and then dataset category information. So in the end, the product is what you saw, and my clients at Stethoscope Science Institute really enjoyed using them, and they were actually able to find the data sets that they really care about in their domain, their specific domain. And one particularly interesting finding they shared with me is that my search engine was able to find data sets that are actually very relevant, but not obviously so at first glance. So, and they look forward to integrating this function into their website. Thank you.